Before Webb set out into space to reveal the most remote and ancient secrets of the cosmos, Paul Githner said, "I think the greatest promise of the James Webb Telescope is that it will provide answers to questions that no one has thought of yet." And indeed, the Deputy Technical Project Manager at NASA's Goddard Space Flight Center was proven right by his prognosis. Today, we are wondering how it's even possible for Webb to detect structures in space that seem simply impossible according to our established models. But how do you deal with discoveries that are so inexplicable that they even stand in stark contradiction to current cosmology? In the context of this astronomical dilemma, there is currently much talk that the James Webb Telescope has practically overturned everything we thought we knew about the cosmos and the Big Bang. But has our understanding of the universe really been destroyed? Well, the bottom line is that the truth is somewhat more nuanced, but that also makes it much more exciting. To get a sense of the extraordinary capabilities of the James Webb Telescope, it's worth looking at the following example. In theory, the $10 billion device could detect the heat of a bumblebee on the surface of the Moon from Earth. In practice, however, Webb did not find any fluffy insects in the depths of the cosmos. Instead, it found a whole series of mysterious objects that simply do not match our tried and tested cosmological models. First and foremost, of course, are the sensational universe breakers. After Webb's near-infrared camera, NIRCam, examined a section of the sky near the Big Dipper, experts identified 6 reddish points of light in the images that turned out to be real mysteries. Based on the redshift, scientists at Swinburne University of Technology in Melbourne determined that the emitted light had taken more than 13 billion years to reach our earthly eyes. We are therefore dealing with structures that existed just 500 to 700 million years after the Big Bang. Furthermore, the characteristics of the light points suggest that these are very early galaxies, and indeed, galaxies that shouldn't actually exist in this form. Astronomers had expected to find only tiny baby galaxies for this early chapter of the universe. After all, our theory suggests that at that time, there was simply not enough normal matter to pave the way for galaxies the size of our Milky Way today. The experts were therefore all the more perplexed when they were confronted with precisely that. All 6 early galaxies actually already contain more than 10 billion solar masses of stars, and one of them could even have a stellar mass of over 100 billion solar masses. Now, there are basically 2 ways to explain the existence of such early galactic heavyweights. Either the matter density in the young cosmos was 2 to 5 times greater than previously thought, or the galaxies formed in a way that is completely alien to us. Have the universe breakers been solved? In this context, the confusing discovery was unsurprisingly described by experts as a real problem for science. Due to their inexplicable dimensions, the structures quickly earned the ignominious nickname universe breakers. However, they ultimately only laid the foundation for a series of further confusing finds that raised serious doubts about our understanding of cosmic development. Because a few months ago, Webb did it again. With JADE's GSZ 14-0, it added another early galaxy to the star map that existed just 290 million years after the Big Bang and once again turned out to be an astronomical mystery. Although the galaxy already existed at a time when, according to current theory, the first stars were only just being formed, it's already incomparably luminous. The researchers' analyses showed that the structure already contains several hundred million solar masses of stars. But how could such a massive galaxy form in less than 300 million years? In fact, scientists assume that the star cluster took about 100 million years to grow to its observed dimensions. And the spectroscopic studies indicate that several very massive stellar generations had already passed through their life cycles before the galaxy came to the attention of astronomers. But what do these mysterious discoveries mean for the big picture? After all, if we were already mistaken about the structure formation processes in the universe, could it not be that we are also wrong about much more fundamental assumptions, such as the birth of the cosmos itself? Well, who knows? But amazingly, the greatest astronomical crisis of our time now seems to be experiencing a promising turnaround, at least in part. In fact, the latest research suggests that the ominous red light does not actually come from inexplicably star-rich galaxies but instead from active black holes, which are enthroned in the centers of these galactic premature babies. In detail, the mass monsters, with their extreme gravitational force, attract matter, which accumulates in so-called accretion disks. These disks, in turn, consist of hot gas and dust and rotate at a crazy speed of up to 1,000 kilometers per second around the black hole. Study co-author Andrew Taylor of the University of Texas states that this finally solves the serious problem that has so challenged our understanding of the universe. NASA also commented on the new findings and emphasized that, contrary to all the headlines, cosmology has not collapsed. But does that really mean that our standard model is off the hook for good? Well, not quite yet. Because the bottom line of the evaluations of the Webb sample surveys, spanning several 100 million years, is that around 70% of the red dots show signs of gas movements typical of black holes. But the remaining 30%? That's a completely different matter. Furthermore, the black holes themselves are still surrounded by big question marks. After all, it seems that they initially appeared in large numbers about 600 million years after the Big Bang, but then mysteriously decreased again 900 million years later. One explanation for this is based on the assumption that as star formation spread, the amount of dust and gas also decreased, causing the emitted light to gradually shift from red to blue, and thus into a range that the James Webb Telescope cannot detect. But while this theory sounds plausible, it has yet to be confirmed in future investigations. That said, we should not forget that the alleged universe breakers are by no means the only mystery that Webb has already added to the star charts. While black holes in this case still held the key to solving the problem, they are causing astronomers all the more headaches elsewhere, such as the inexplicably massive black hole that weighed in at over 1 billion solar masses when the universe was still in its infancy, just 770 million years after the Big Bang. Is the Big Bang theory wrong? But was the universe really still in its infancy back then? Or could it be that it actually looks back on a completely different past than the Big Bang theory suggests? Basically, the Big Bang theory assumes that the universe unfolded from a tiny starting point about 13.8 billion years ago. Or, to be more precise, space-time and matter emerged from an original singularity. But although the Big Bang theory has long held a prominent and established position, there are more and more researchers these days who are turning their backs on this long-standing idea. Among them is the British physicist and Nobel Prize winner Roger Penrose, who does not see the Big Bang as the literal beginning of everything but merely as the explosive transition between two cosmic chapters. In fact, Penrose is convinced that the universe has always been subject to a fixed cycle of destruction and rebirth. In detail, the cosmos would always expand until all matter has disintegrated and become light. This extreme environment, in which nothing has a time or space reference to one another, would inevitably lead to a new Big Bang over and over again. There is no question that this idea sounds extremely exciting on paper, but here's the kicker. Penrose actually claims to have found tangible evidence for this model. More specifically, he's referring to some striking circular spots in the cosmic microwave background, CMB, that were detected in both the Planck and WMAP satellite data. And just to clarify, the CMB is a relic from the early days of the universe, created around 380,000 years after the Big Bang during the so-called recombination epoch, and it fills the entire universe to this day. And Penrose believes he has detected a series of telltale Hawking points in it, relics that come directly from a precursor universe. Because when black holes evaporate completely into Hawking radiation at the end of a cosmic chapter, they would take all of the radiated energy with them into the subsequent universe in the form of a single Hawking point. In view of this exciting discovery, and all the cosmological inconsistencies uncovered by the James Webb Telescope, is it possible that our world does not correspond to the universe at all, but only to the current cycle? Well, that is precisely the question, because the rest of the research community is not exactly unanimous in its approval of Roger Penrose's statements. But whether it's the Big Bang, a cyclic universe, or something completely different, the bottom line is that some fundamental questions remain unanswered either way. After all, what led to the universe coming into being out of nothing 13.8 billion years ago, or at some point earlier? Was there a trigger, or was it mere coincidence? And what was before that? These are all questions to which experts do not yet have any clear answers. But who knows? Maybe the next hot lead is just around the corner, waiting to be discovered by another exciting web find. And now, we'd like to point you in the direction of the subscription button. Simply click the thumbs up and subscribe to never miss a new video from us again. We'll see you soon.